The Metropolitan Spatial Data Catalog is a repository for the publication of metadata describing the spatial informative levels. The informative levels included in the data catalog are extracted from a cytometropolitan context through the semantic package, moving from geochemical up to phenomenological, from the global to the local. The Metropolitan Spatial Data Catalog allows people to search for data with information such as where and how to access and connect to spatially referenced data sets, who, when, and how the data was created, how often it is updated, the geographic extent of the dataset, as well as the rights and restrictions that apply to the dataset. The informative levels are represented especially by the spatially referenced dataset related to the metropolitan keywords and concepts that are collected to interpret the metropolitan context through the semantic package. They could be physical state and quantifiable variable and indicators such as millimeters of precipitation per month, number of water pumps installed, and so on, or qualitative ordinal and nominal variables and indicators such as religious affiliation, people that experience positive interaction in public spaces, early stage investments that continue to second and third rounds. Big data has been one of the buzzwords over the last years. In particular, geospatial data are referring to any geo-referenced information. There are various types of spatial data: maps, both raster and vector, imagery, derived data, publicly crowdsourced data, open source data, tagged data, temporal, classified or non-classified data, video, sensors, and many others. But in the decision-making process, big data is better data. Therefore, it is necessary to follow some principle to select appropriate data sources. Since the collected data is only a snapshot of the reality, decision makers shouldn't rely exclusively on it. Instead of focusing only on the data, one has to test and question it in order to decide whether the data is reliable for a specific purpose. Data is available to the widest range of users for the widest range of purposes. To trust accessibility, data should be available at a stable internet location and in a stable data format for as long as possible. Data is structured to allow automated processing. Data is useful when a complete documentation on the format and meaning of data exists. Metropolitan cartography is oriented towards the use of public and open data. It is important to know what data is available and under which licenses, terms of service, and legal restrictions. Data is available in a format over which no entity has exclusive control, but with a responsible party that supervises the collecting process history and overall quality. A necessary condition for the existence of the Metropolitan Spatial Data Catalog as open data infrastructure is that data and information are shared by a large number of infrastructure users. And when metadata standards for open data infrastructures are interoperable, data described using different metadata standards can be combined and the use of the data becomes easier. Metadata needs to be described, contextualized, and provide access to digital objects, specifically data. There are hundreds of specific formats used as a standard, but the ones widely used are Dublin Core, the Comprehensive Knowledge Archive Network, the e-Government Metadata Standard, the Data Catalog Vocabulary, INSPIRE, and the Common European Research Information Format. For example, INSPIRE regulation is mandatory for datasets with geospatial coordinates and web services in the European Union. INSPIRE metadata allow people to provide context to an open dataset, such as the person who created it, the projects in which it was used, the organization that owns it, the publication in which it was cited, and many others. These are the INSPIRE general requirements for metadata. Metadata point of contact, that is, who wrote the metadata. Identification, that is, resources title, identifier, abstract, resource locator, language. Topic category, for example, economy, elevation, environment, and so on. 3 keywords for the semantic search. Geographic, that is, the coordinates bounding box or the administrative boundaries. Temporal extent, that is the period of time covered by the content of the resource, the date of creation and publication, the date of last revision and frequency. Quality and validity, that is the statement on process history and or the overall quality, the spatial resolution that implies the equivalent scale and the resolution distance. Constraint related to access and use. Responsible party, that is the organization name and context. Without this information, it becomes more difficult to work with datasets. Metadata must be highly complete, consistent, and trusted. Trust is a measure of the perception of and confidence in the data quality from those who utilize it. Metadata is important in assessing data quality at the syntactic level. There is strong evidence that data quality problems are widespread in practice and that relying on poor data or uncertain quality leads to less effective decision-making. Each information system project needs to define its own quality criteria according to the planned usage framework. From an operational point of view, to identify high-value datasets, it is necessary to rank resources according to the user's purpose. In particular, to measure spatial metadata quality, it is fundamental to ensure completeness and openness of data documentation, data transparency, checking data collection methods or data acquisition mechanisms, and validating the coherence between data and the research conclusions. Accessibility through open data licenses. The reliability on the authorities to release geospatial sources. A legal perspective on open data focuses on challenges related to open data legislation, including Freedom of Information Acts, licenses, official open data policies, open government directives, memorandums, and declarations. Even if the license is clear to the data user, it may not be clear which license applies if various datasets with different licenses are combined. If it is unclear under which conditions a dataset can be used, potential users may be reluctant to use the data. The most recognized and used standard licenses which can be used for data and datasets are Creative Commons licenses. They permit the free of charge copying, reuse, distribution, and in some cases, the modification of the initial creator's creative work without having to obtain permission every single time from the rights holder. The main Creative Commons licenses offer a series of baseline rights with attribution as a core requirement. Using attribution as a license element, you must credit the work's creator. Creative Commons Zero. CC0 is a tool created by Creative Commons to facilitate the release of content, data, datasets, and databases into the public domain. Open Data Commons. Open Data Commons has produced open solutions specifically for data, datasets, and databases. For example, in the Open Data Commons Open Database License, you must attribute any public use of the database or works produced from the database in the manner specified in the Open Database License. Metadata systems are concerned with documentation of data quality components. In order to assess data quality, it is necessary to satisfy the criteria of completeness, uniqueness, timeliness, accuracy, and consistency. Completeness is the proportion of stored data to the potential of completion. It is the measure of the absence of blank values, that is, null or empty string, or the presence of non-blank values. The dimension of uniqueness is characterized by stating that no data entity exists more than once within the data set, and that exists a unique key to access that entity. Otherwise, the risk of accessing outdated information increases. Timeliness reflects how up-to-date the data is with respect to the task it is used for. Volatility refers to the length of time data remains valid. Delivery time refers to when data is delivered to the user, and age refers to the age of the data when first received by the system. It is fundamental to recognize the volatility of datasets depending on selected informative levels. When two informative layers with different volatility or age are overlapped, it is necessary to evaluate the resources according to the purpose of the map. Currency can measure how up-to-date the information is, and whether it is correct despite possible time-related changes. The real world can be represented by the Entity Attribute Value Model. In this model, entities represent real-world objects and phenomena, such as streets. Attributes specify the relevant properties of these objects, such as width or number of lanes in a street, and values give the qualitative or quantitative measurements of the specific attribute. To be correct, data attributes and values must have the right value and must be represented in a consistent and unambiguous form. Using geographical information, it is important to cope with spatial accuracy, that refers to the accuracy of the spatial component of a database. The most common measures are horizontal error, that is the distance measured in x and y axis simultaneously, and vertical error, that is the distance measured in z axis. Consistency refers to the absence of apparent contradictions in a database when comparing two or more representations. Data across all systems must reflect the same information and must be in sync with each other. In order to use the tools and technologies, the user needs to have certain skills and knowledge, such as knowledge of disciplinary analysis to conduct calculations and skills to link datasets to each other. All spatial data are of limited resolution because no measurement system is infinitely precise. Resolution is also limited because geospatial databases are intentionally generalized. The concept of spatial resolution is well developed in the field of remote sensing. The more pixels are included in a remote sensing image of a certain area, the higher the spatial resolution is. In other words, more details can be observed. The concept is applicable without modifying to raster databases. For vector data, the minimum mapping unit size depends on map scale. Linking and combining data requires sophisticated knowledge. For example, it might be necessary to overlap data from different spatial and temporal resolution or with different spatial coverage. It is fundamental to pay attention to the purpose according to scale of representation and quality of data. Build a Metropolitan Spatial Data Catalog by collecting the resources of the informative levels. For each informative level, evaluate if related metadata are complete, consistent, and trusted. Ensure that spatial databases are accessible, checking the applied license. Assess data quality, focusing on completeness, uniqueness, timeliness, accuracy, and consistency criteria.